So 4.5 billion years ago, when our solar system formed, there were actually 2 planets that hosted liquid water at the surface. One of those you know very well, Earth, right? Earth was covered in oceans and lakes and rivers. And through time, it actually developed life. And that life thrived. As you know, it changed the atmosphere, it changed the oceans, it changed even the way the rivers flow. And what we're really curious about is that time when life formed. So it was probably between about 3.8 and 3 billion years ago. But because Earth has so much water and plate tectonics kind of moving those continents around, it's actually very hard to get at the rock record from that time. So we look at the rocks, we understand environments that are formed, environments that are preserved in the rock record, where each of the stories of previous surfaces of Earth are recorded. And yet it's hard to see the rocks from 3 billion years ago because they've changed so much on Earth. We have another option. Mars also had flowing water at that time. Mars also had an environment where life could have formed. It had lakes and rivers and maybe even oceans. And on Mars, there isn't a magnetic field to protect it from the solar radiation. And so in that time from about 4.5 billion years ago to about 3 billion years ago, it had a lot of surface activity. It could have been very similar to Earth. But then the solar wind blew the atmosphere away and prevented liquid water from being stable on the surface. And so the record from that time is actually very well preserved on Mars. So we can go over to Mars with, say, a rover and investigate the layers that formed in that time very early in the solar system when life was probably forming on Earth. I have the privilege of working on the science and operations team for the Curiosity rover. It's about the size of a small SUV. It's 2 meters tall. It's the most complex rover we've ever built and sent to the surface of another world. And it is currently investigating layers of rock that formed on Mars between 4 billion and 3 billion years ago. And each of those layers of rock contains a story of an environment at a certain time. And as we climb up, it's in a crater where there's a lot of these layers preserved. As we climb up through the layers, we get to see younger and younger periods of time. The rover has 11 different scientific instruments. Several of them are actually mounted on a 2-meter-long arm. You can't actually see the arm in this picture because it is busy taking the selfie that you are looking at right now. So this is a real selfie taken by the rover, but it can extend that arm and kind of reach out and either drill into the rock or observe the surface of the rock. And that's kind of what I'm depicting here with this ring, but let me zoom in. What does that actually look like? So when it takes a chemistry measurement, it takes the chemistry measurement of a little spot on the rock that's about the size of a penny. We did also stick a penny on the rover for scale, so this is a penny from the rover. We told NASA about it after launch. But that's what we typically use for scale in the field. So there's our chemistry measurement. It's of the surface of the rock, and we get to learn about this one layer that we're preserving in time. But one chemistry measurement of this entire rock can't necessarily tell us the whole story. So we look across this one layer that we think formed in a series of rivers. And so these rivers are flowing down into the crater, depositing sandstones. So this is an example of one of the sandstones that we looked at. And when we looked at them, we realized they had actually a wide variety of different chemistries. And so initially we thought maybe there were a lot of different volcanoes on Mars that produced rocks with all different chemistries. Maybe the interior of Mars is more complex than we thought. And so I said, let's take a step back. We're looking at rocks deposited in rivers. So how did these rocks form? When we're looking at sandstones, how did the rocks form? Well, there are volcanoes initially that create layers of rock that are outside the crater. But then those layers of rock break up into particles that are carried into the crater, either by water or by wind. And then in the base of the crater, once you have a pile of sand, it's cemented by groundwater to become a sandstone. When I looked at the different chemistries, I actually sorted them out by grain size and looked at each of these different components. We got over 100 analyses. And I realized that when you sorted them by grain size, it was actually a difference of which minerals were in which grain sizes of the rock. So I said maybe the volcano produced a rock that had minerals of different grain sizes. And we looked around closely and we found this example. It's about a fist-sized rock that actually did get carried down by a river into the volcano, into the crater, and it's straight from the volcano. And it shows that the volcano produced really large crystals of a light-toned mineral and small crystals of a dark-toned mineral. And so this is the key. It tells us that, in fact, the variety of chemistry, the wide range of different chemistries that we saw are actually from one volcano and some very powerful rivers. The rivers were probably knee to waist deep, flowing into Gale Crater and breaking up these rocks and sorting out the different minerals as they deposited them on the floor of the crater. So now we've solved the mystery of one of the layers, but we keep climbing. So Curiosity is climbing today. I was just helping operate it yesterday, and we are still climbing up the layers in this crater. We're actually climbing through layers from a lake. And that lake actually lasted for more than 10 million years on Mars. And as we climb up through each layer, we apply similar techniques. We say, okay, what were the influences? Was it the river? Was it the water? Was it the volcanoes outside the crater? What causes all of the chemical variation we see? And as we answer those questions, we learn about how Mars actually can tell us way more about how we exist here on Earth. Thank you.